All right, page 218 in your textbooks. You did numbers 2 through 12 the even a couple nights ago. If you didn't do it a couple nights ago, you did it last night. So let's take a look at page 218, 2 through 12 the even. Number 2, you were asked to convert to slope-intercept form and identify the slope and the y-intercept. There is something we could do right off the bat with number 2 if we wanted to, just make the equation a little easier. Thoughts, class? I could knock a 5 out of everything, so before I even try moving stuff around, if I wanted to go negative x, positive 3x equals 6, I could. Not necessary, you'll get the correct answer even if you don't, but you could do that. I just like little numbers, what can I say? And so if I want to get this in slope-intercept form, speaking of little, Kendall, why don't you help us get it in slope-intercept form?
You can move the x over positive. You have 3y equals x plus 6. And then dividing by the 3.
Again, you do the same thing if it were a 5x and you were dividing everything by a 15. You'll get the same answer.
Y equals 1/3 x plus 2.
Good, so that we have a slope of
1/3.
and a y-intercept of 2. Number 4, we were supposed to find slope-intercept form of the line that goes through 11, 13, and negative 4, negative 8. And what do we do to find the equation of that line, Audrey?
You do the formula.
What formula?
The slope formula.
Slope formula. Okay, what's the slope formula? The slope formula?
Yeah.
Someone help. Genesis, what's the slope formula? There we go. Okay, so Audrey, now that we've been refreshed on slope formula,
Do negative 8 minus 13 and negative 4 minus 11. You get 21/15.
well, initially negative 21 over negative 15, we can cancel off those negatives, and we can reduce by
3
to get?
7/5.
All right, so first step, if we're going to find the equation of the lines, we've got to get the slope of the line at 7/5. Then what?
Then you plug in the thing to y equals mx plus b.
All right, so you'll write out y equals mx plus b, and you said you plug in the thing. What thing?
13.
Okay, for the y.
And then you do 7/5 times x plus b.
Well, but instead of x, we could put
11.
11, since we put 13. If we've done negative 8 here, we do negative 4 here, but I like positive. Put the 11 over 1 plus b. Okay, pray continue.
You get 77/5, and then you move it. And
As a negative 77/5.
yeah, and I didn't get that, so
And we pull out our calculator, which is what she's doing now. And we do 13 minus 77/5. We get a b value of
12 is
12. Again, negative 12/5. Negative 2 and 2/5, but make it improper fraction. Your calculator can do that. Negative 12/5. So what's the equation of the line that goes through these points?
y equals negative 12, no, 7/5 x, negative 12/5.
There we go. And how many have that answer for number 4? Just a few of us. Okay, questions? All right, number 6. Are those lines parallel, perpendicular, or neither? Michael?
Perpendicular.
They are perpendicular because
They have the same negative reciprocal slopes.
they have negative reciprocal slopes. Number 8. Want the equation of a line parallel to the one they gave you in number 8 that happens to go through negative 5, 1. Talk me through this one, Genesis. If it's parallel to this line, what does that mean?
The slope is negative 3.
1/2. There we go. So the slope then is going to be 1/2 because it's parallel to this. This slope's a half. This slope's also going to be a half. And if it goes through the point negative 5, 1.
You do y equals mx plus b. And you do 1 equals 1/2 times 5, negative 5 plus b. You get 1 equals negative 5 2 plus b.
All right, good.
And then you bring the negative
positive 5/2. And by the way, while we do it, we could rewrite the 1 as 2/2. And so that would give us a b value of,
3.5.
or 7/2. And so what's our equation?
Y is 1/2 x plus 7x.
Good, and nothing wrong with a 3.5 or a 3.5 there. It did ask for it in standard form. We never do that. How many had that answer? For numero ocho. All right, and then numero 10. We want a line perpendicular to that one through the point 3, 8. So if it's perpendicular to y equals 6x plus 7, what does that tell us, Brandon?
Negative reciprocal slopes.
So
Our slope is negative 1/6.
negative is 6, then it's going through the point, I think it's 3, 8, C. And we're going to do all the same things. We're going to plug in the m, we're going to plug in the y for the 8 as the 8, the x is 3. We're going to solve it. What did you get for your answer?
17 ops, and then the equation was y equals negative 1/6 x plus 17 ops. I swear.
What seems to be troubling your soul?
My pens. 10.
How many had y equals negative 1/6 x with 17 halves? Questions on that?
Where did it go?
Abby is completely unperturbed by it all. All right.
I had negative 1/6 x negative 7 and 1/6.
7 and 1/6. All right. 8 equals negative a sixth of 3 over 1 plus b. I would cancel or do 1, 2.
world?
Okay, if you're going to have issues, let's have the issues quietly, please. We're going to bring the negative a half over as a positive a half to get 8.5 equals b. So that's what we should do.
I think I mixed it with another one because I multiplied negative 1/6 by negative 5.
Oh, yeah, that's what you did. You used the negative 5 and 1, perhaps, from the previous problem. Number 12. They tell us these values have constant variation, or direct variation, rather. And that's because it couldn't possibly be inverse, because inverse means the product is always the same, and the product's not the same. What is the constant value that is used to get the y value here, Maddie? 9. So our equation would be? Well, k is 9, right? So the equation for the direct variation would be? Y equals 9x. How many had that for number 12? Questions on that? Any questions on that part of the homework? Then let's review what we were looking at yesterday as you get out your graphs from last night, the other part of the homework, the new homework. We've been talking about quadratic functions. What is a quadratic function? Genesis? Okay, what is it that makes it quadratic? It's quadraticness. Quadracity. I don't think that's a word, but anyway. Class? X squared. The x squared makes it quadratic. So it's a function that has x squared in it. What's the general look of a quadratic function, Kendall?
F of x equals ax squared plus bx plus c.
There we go. But what we were doing typically is taking these quadratic functions from the general form, converting it into what we call the standard parabolic form, because we'll get a parabola when we graph. What does that standard parabolic form look like, Michael?
A times the quantity of x minus h squared plus k.
There we go. And so with this, it told us where the vertex was. The vertex is going to be what, Audrey? HK. And of course here you can find the vertex as well. Remember, you factor out the a, take negative half b, and all that kind of jazz. But this gives it, I think, a little bit more directly. And this is what we were working on. Now, when it came to graphing the quadratic, we started in what I call the base form of the parabola. Because the most basic quadratic function ever, Abby, is simply?
It's x squared.
Good. F of x just equals x squared. You cannot have a more basic parabola than this. You need squared to have quadratic. I've got squared. I have literally nothing else, but I have squared. So this is the most basic quadratic. For the base quadratic, where's the vertex of the parabola class? 0, 0. And then when we go to graph it, we'll start at 0, 0. And from the vertex, we'll go out 1, up, then out 1 more, now up 3 more. Then we'll go out 1, up 5 more, then out 1, up 7 more if you really wanted to keep going. Then it would be over 1, up 9, over 1, up 11. And just keep on going, right? With those odd numbers, okay? We're not going to graph that far because we're lazy, but that's the basic idea. Well, we said we could cause this vertex to shift. We could cause it to shift vertically by doing what? What would cause a vertical shift up or down to my parabola? Anyone? Okay. Add a k value to the end or subtract a k value. So we would say f of x equals x squared plus or minus k, where a positive k value shifts the parabola up and a negative shifts it down. It's still going to look the same, it's just not going to have the vertex at 0, 0 anymore. It's going to be shifted up or down. We could also shift the vertex side to side horizontally. How might I shift the vertex side to side? Class?
H, add something in that's squared.
Good. With the x in the quantity, x minus plus h squared. The reason for the minus plus is that the minus shifts forward and the plus shifts backward. It just helps us to remember, go opposite of what your intuition would say. And so we practiced graphing a few different functions on page 209 now, if you'll turn there. Page 209. Number 11, we were asked to graph f of x is equal to x squared negative 5. And again, it's just going to be your normal, everyday parabola, but class, it's going to be shifted down 5. There we go. It's going to be shifted down 5. So same old parabola, same over 1 up, 1 over 1 up, 3 over 1 up, 5, and so forth. You're just going to shift the whole thing down 5. So quick sketch here, but somewhat accurate because I actually have graph paper. All right, we're going to start down here at negative 5. Check your work on 11. And then you're going to go over 1 up 1, over 1 up 3, over 1 up 5. And when you connect the dots, you should have gotten a parabola that looks something like that. How many got that for number 11? All right, now on number 12, we got an f of x equals x squared plus 3. What are we doing to that parabola, class? Up 3. Good, Brandon. So instead of putting the vertex at the origin, we go up 3. Not 3 from where the last one was. 3 from the origin. Everything is considered to start at the origin. We're going to go up 3. Then over 1 up 1. Over 1 up 3. I don't have room to go over 1 up 5. It's somewhere up there. So I'm just going to go with that much, and there we go. 11 and 12 should have been graphed together. Should have looked like this. How many had that for 11 and 12? Questions? Okay, so remember, if it comes after, at the end, this is vertical. In the parentheses, though, as we come to number 13, in the parentheses, that's horizontal. So on 13, when it says x plus 4 squared, this is going to be horizontal, and hence the letter h in the basic form, in the standard parabolic form. Which direction do we shift 4, class? Backward 4, to the left 4. Again, it says positive 4, but we're going to shift negative 4. And then other than that, it's over 1 up 1, over 1 up 3, over 1 up like 5, something like that there. And so we connect the dots down through with a nice smooth curve. And again, it's just the same parabola we keep graphing over and over again, but shifted backward 4. How many had that for 13? Number 14. What are we doing? This time we're shifting forward 4. So the exact same thing with this time, we'll shift forward 4. So we'll put it here on the positive x-axis, and then going into the first quadrant. Over 1 up 1, over 1 up 3, over 1 up 5, something like that. And we'll connect down through. And there we go. How many had that for number 14? Questions on 14? Then they get a little bit more fun on 21 and 22. Number 21, there's actually 2 changes. What are the 2 shifts we have to do to 21, Maddie? I promise I didn't do that on purpose. Down 10 and to the left 3. So we're going to go backward 3 units and then downward 10 units, which would be right about there, which doesn't quite fit on my graph. And then over 1, up 1, over 1, up 3, over 1, up 5. Is that 5? Yeah. Over 1, up 5. And here, now you really might, because you're still in the 4th, down here below the x-axis, maybe do go over 1 and up 2, 4, 6, 7. And go ahead and just give yourself a little bit more drawing room so we at least come up above the axis here. Okay? So very deep, going down 10. How many had that for number 21? Questions on 21? Number 22, what are the 2 changes that we're making to our base form here? Not nearly as dramatic this time. Genesis?
Over 1.
Which direction? Forward or backward?
No, forward.
Forward 1 and
Up 1.
up 1. Forward 1 and up 1. So our vertex this time will be right at 1, 1. And then over 1, up 1, over 1, up 3, over, you get the idea, right? So something like that. And how many had that? All right. How many of you, as you were drawing 6 different parabolas last night, started to get a little bit of a feel for it, feel like you're able to draw them a little more smoothly than we did yesterday in class when we really done it for the first time? How many, it's still just you, just like, I am no artist. All right, bless your heart. All right, just do your best. Let's go ahead and progress now. I feel like, are there any questions on the shifts that we did yesterday? Or do you all feel like, no, we got the shifts now, let's move on. All right, so let's move on. Next thing in your notes, because there's more that we can do to our parabolas. Shifting it up and down and back and forth, it's not enough for us. We can do more things. Like a roller coaster, right? It just bumps you all over the place. And then, like, I can handle that. I can handle being bumped up and down and dropped down. And it's when the roller coaster goes upside down, and then my stomach goes upside down, and I don't do upside down stomach. That's just not me. So I don't do upside down roller coasters, which is most roller coasters. No offense, you know, I'm not bothered by people who do like roller coasters. Just I don't need that in my life. I don't need upside down stomach syndrome. But we're going to do that to our parabolas because we don't care. And so next thing in your notes is called vertical reflection. Vertical reflection. Or flip, which is plain English I like to use. Okay, we're going to flip the parabola. All right, and you kind of already know how this works. Okay, so the basic form, remember, is f of x equals x squared. That's the base form. If you put a negative in front, you flip the parabola. You're like, we already know this. Yeah, I know, we just haven't put it in the notes in this section yet. So now we're putting it in this section. So, in other words, you start at your vertex, and you go over 1, down 1, over 1, down 3, over 1, down 5. See, whoa. Okay? If there's a negative in front of the x squared. Seem pretty easy? Okay. So if we were to actually graph this, not trying to insult anyone's intelligence here, but now it actually begins to look a little bit like that initial rise on the roller coaster. Okay? See, my first roller coaster, it was in the dark, like it was a nighttime activity, and my former best friend had told me that we should ride the roller coaster, and so I couldn't even see the whole roller coaster. I just saw where you got on, right? And we're going up the hill, and I'm like, okay, whatever. I've never done this before, but here we go. It's like a senior in high school. We were poor. We didn't have money to go to amusement parks, and so I had no idea what was happening. I had no idea what was about to happen. Just all of a sudden, we're slowly going up, like, okay, whatever. I know it's going to go faster here in a minute. I was not prepared for, like, my body to go down that fast and my stomach to not go down that fast. And it's just like, you know, I started going down. I tried to scream. I couldn't even scream. It's like my stomach was blocking my throat. It was really weird. And so the next time I'm like, you know, after like a minute or two, I could start screaming then. So then he talked me into doing it again. I'm like, okay, first time I didn't know what to expect. Second time I got this. I still was not ready for it. And the third time I'm like, I got this. So on the way up, I started screaming. And everyone just like, I'm going to do this. I got this. So it wasn't quite as bad that time. But I was like, you know what? I don't need this in my life. But how many love roller coasters? You like the loops and the twists and the turns and just love being thrown all over the place.
I love
Goliath
that
at
stuff.
Six Flags?
Yeah.
See, I saw Goliath, I'm like,
Never been there.
no. I'm like, no, not doing that, yeah. Anyway, alright, so if I were to graph f of x equals negative x squared, where's the vertex going to be?
0, 0.
At 0, 0, of course. It's where the base form goes. But again, instead of going over 1 up 1, over 1 down 1. Over 1 down, 3 more. Over 1 down, 5 more. And once again, we'll draw the curve. And so there we go. This is, that up, 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 and then like that. All right, questions on that? Now, obviously, we can flip and shift too. For instance, if I had f of x equals negative x squared plus 2, we're going to do a shift first, class, up 2. And then we're going to flip it. Over 1 down 1, over 1 down 3, over 1 down 5. And it's the same thing. You just shift it up 2. Easy enough?
Looks like a whale.
A whale. Okay. Okay, I kind of see what you're saying. They're the mouth of the whale. Okay. All right. So how about f of x equals negative x negative 1 squared? Okay, what are we going to do to this parabola, class?
Up the way.
Right one.
We're going to shift the whale which direction?
Right one.
To the right one, forward 1, and then flip it. So now the vertex is over here. The whale is swimming. All right. Over 1 down 1. Over 1 down 3. Over 1 down 5. Like that. And there's, by the way, notice when I trace one side, just to make sure I get the curve, I like to retrace that starting side again, just to make sure I have the correct curvature. That way it's nice and symmetric. But again, it's the same thing we've been doing. In fact, if you really don't like going down, flip the graph paper over once you get your starting point. I can't flip the chalkboard, but you can flip the graph paper even. If you're just like, I got really used to going this way. Or if you discover you like this way, then when you don't flip it, flip the graph paper over and do it this way. What, there's all kinds of ways to cheat the system and do it easier. So at your seats, I want you to set up a new Cartesian plane, and I want you to graph f of x equals negative x plus 3 squared minus 1. You do this one at your seats while I erase the whale. That's what Ahab wanted to do.
Uh-huh.
Set a new Cartesian plane, and then graph f of x equals negative x plus 3 squared negative 1. When you see the Algebra 1 students, you can tell them you're way cooler than them because all they're doing is drawing lines. Yeah.
We're drawing whales.
Whales and roller coasters.
Whoa. I don't think I'm artsy enough for this.
Well, just gonna have to do your best. I will say this is one section where those who are more artistically inclined, they tend to enjoy it more and they tend to do better. And then those who are less artistically inclined tend to, hate it. But, nothing I can do. Just have to suffer.
Wow. Do they have like stamps for the basic parabolas? And you could just stamp it?
I don't know. Maybe you could make one.
In it?
You said he was genius? Hey.
Whoa.
Hey, see, she doesn't hate
She
you.
called me a pretty skittle too.
And an ugly skill.
She was lying to you, Michael.
You're fruity? Oh my.
Wait, what?
Be careful of the things you don't repeat everything your sister says to you. It's not always nice.
Oh, you should hear what my brother told me.
No, we're on the air right now.
No. Like,
All right, so Kendall,
how's it going?
what do we need to do to graph this parabola?
Okay, so, it's -3, -1.
Okay, we're going to shift backward 3 and downward 1. Okay, -3, -1's our vertex. And then from there,
You go down, you go over 1 and down 1, and 1, and then over 1, down 3, and then over 1, down.
I think I have room. Just barely. All right, and then we connect the dots and make our parabola look reasonably nice. If it's an electronic one, it's an Ebola. But it's anyway, yes, sir.
Can you have us graph one with a -3k so we can make another wheel
A -3K?
instead of a -1?
Oh, maybe you can do that on your own time. But we've got to move on. All right, so here's the only thing that's been, okay, admittedly kind of boring this whole time, is every parabola, like you could literally have a parabola stamp, right? Every parabola looks the same, it's just whether it goes up or down and where do you put it, right? You can change the shape of the parabola. Parabolas do come in other shapes. Not every parabola comes down this much. Some parabolas may be more, flat, some may be even taller, like a sharpened pencil, for instance. So we can change all of that with the next thing in your notes, which is vertical stretch or compression. Vertical stretch or compression. Vertical stretch and compression. For this, we turn to the a value. F of x equals ax squared. I have not lied to you, but I have not given you full truth yet. I've told you, you go over 1, up 1, over 1, up 3, over 1, up 5, and so forth. Technically, from your vertex, you go over 1, up 1a, over 1, up 3a, over 1, up 5a. It's just that a has always been a 1 to this point. We haven't had any numbers, right? Here, the a value is a 1. So it really has been 1, 3, 5, 7, and so forth. But technically, it's 1a, 3a, 5a. So this a value right here is what's either going to stretch or compress the parabola. So, for instance, couple of things. If a is the bigger the a is, the more stretched you're going to get, right? So if you write this in your notes, if the absolute value of a, because we don't really care about the negative is a flip, right? So forget the sign on the a. If the a's absolute value is greater than 1, you're going to get a stretch. And then if the absolute value of a is less than 1, in parentheses you could say if it's a fraction, a half, 2/3, a fourth, 1/5, whatever, then you're going to get compression. So if you have a bigger value, you stretch it out more. Smaller value, less than 1, meaning, some kind of fraction, a half, a third, 2/15, whatever, you're going to get compression. So let me go and show you what that's going to look like. If I had, for instance, f of x is equal to 2x squared. Well, notice, I don't have any shifts for this particular curve, right? So that means my vertex is still at 0, 0, right? And then from here, we're going to go over 1, not up 1, up 2. Then we're going to go over 1, up not 3, but 3a, or 3 times 2, or 6. So over 1, up 1, 2, 3, 4, 5, 6. And that's really all the room we have. There's no sense trying for the next one. And so now notice when we connect the dots here, we still need a smooth curve, but it's going to reverse course. There we go. A little faster than it did before. And it looks narrower because it's been stretched. It's kind of like, You know, the little kid when he's in like 5th and 6th grade, he's kind of chubby. And then in like junior high, he starts to grow and he doesn't look chubby anymore. I remember being, I think it was probably 11th or 12th grade, so my classmates and I were looking at our elementary school pictures. Like, he was so chubby back then, and he was so chubby back. And it finally dawned on me, we just all finally grew, and so the chubbage stretched out. It looks like it's skinnier. It's not skinnier, it's longer, but it looks skinnier. So it's vertical change, but it looks like it's a horizontal change, almost like it's been squished in a little bit. But it's a little bit of a sharper turnaround there. Does that make sense? Look at this one here. What if we did the opposite? What if instead of f of x equals 2x squared, we said a half x squared? Well, here again, vertex is still going to be class at 0, 0. But here it's going to be over 1 up a half. Now here's the fun part. See if I can zoom in just a little bit here. From these points, over 1 up 3 halves, or 1 1/2. So I was already at the half mark. If I go over 1, I have to go up 1 1/2. Well, there's half and there's 1, so I'm here. Do you see that? Then it's going to be over 1 up 5 halves. So over 1 up 2 1/2. And so I'm here. And if I wanted to go another level, it'd be over 1 up 7 halves. So over 1 up, there's a half. 1 1/2, 2 1/2, 3 1/2 is the same thing as 7 halves. Notice as we connect the dots here on this parabola, it's not as pronounced, right? It's more of a gradual, still not quite bowl-shaped, but not nearly as steep as what we're used to seeing. Why? Because it's been squished down. Does that make sense? Kind of like, stop staring at me. I'm trying not to. All right, squished down. Questions on that one? All right, so what if we put both of those thoughts together and said f of x is equal to negative 3x squared? Where's my vertex class? 0, 0. But now I'm going to do two things. First of all, I'm going to go over and down. But I'm also going to go over 1 down 3. And then I'm going to go over 1 down 9. Uh-oh. Over 1 down 1, 2, 3, 4, 5, 6, 7. That should be 8-ish, 9-ish. And then over 1, 2, 3, 4, 5, 6, 7, 8, 9.
Would you like a ruler?
4, 5, 6, 7, 8. One more. Okay, let's just call that good. And so we connect the dots down and something-ish like that. That's something like that. All right, where it's very tall and skinny now, but flipped over. This has stretched it, making it appear skinnier, and this flipped it. Does that make sense? Okay. So I want you to write this in your notes then, the full form of all the fun stuff you can do to a quadratic function. Write this down. F of x equals positive negative a, x minus plus h squared, plus or minus k. This is going to give us the full gamut of what we can do to a quadratic function. Let's label every part of what means what. Because that's really the key for you, is keeping straight of what you do when you see things. First of all, the sign right at the very beginning tells you whether or not to flip it. So just write flip question mark. Okay? That's the flip. If it's a negative, you flip. If it's not a negative, you don't flip. All right, what about the A? What does the A do? It stretches or compresses. Stretch or compress. By the way, the letter A actually stands for amplitude, in case you're wondering why the letter A was chosen. The H, right here, what does that mean? Horizontal. Shift. All right, and then the positive negative K, vertical. Shift. So we can do all four things to the same parabola if we wanted to. It's just a matter of keeping track of what we're doing when. Look at page 209 at the top of the page. Let's kind of go through these and see if we can figure out everything we're doing to our curve. And then we'll actually graph some of these. Let's kind of talk through it first. Page 209. And looking at number 1, what do we do to the base curve in number 1? Abby?
You just flip it.
All we're doing is flipping it. Nothing else changes. Number 2, what are we doing to that one, Brandon? All we're doing is shifting it to the left 5 or backward 5. Number 3, what are we doing to that one, Audrey?
We're going up 13.
Going up 13 units. Number 4, what are we doing to that thing? Genesis, you. Number 4. We're not shifting it up 3. That would be a plus 3 at the end. The value that's multiplied at the beginning you're going to stretch it 3. So over 1 up 3, over 1 up 9, over 1 up 15 if you had that much room, which you probably won't. Number 5, what are we doing here, Michael?
Compress.
This is technically compressing. It's stretching it 7/9, but that's less than 1. So over 1 up 7/9, over 1 up 21/9, bless your heart, over 1 up 35/9. Aren't you glad they didn't actually ask us to graph that one? But that is compression. Good. Number 20 or number 6. What are we doing, Kendall? Going down 26 units. Number 7. What are we doing, Maddie? Stretching it a lot, right? Over 1 up 15. Over 1 up 45. That thing's going to look almost just like a, not even a V. It's almost going to look like a straight line, as much as you'd have to zoom out just to make it work. Number 8, what are we doing there, Brandon? Compressing it, so it's over 1 up 1/3, over 1 up 3/3 or 1, over 1 up 5/3 and so forth. Number 9, what are we doing, Abby?
You go this way 12, right.
Forward 12, there we go. We're going forward 12 or positive 12 or to the right 12. And then number 10, there's actually 2 things here. Audrey?
You flip it and you stretch it.
Flip it and stretch. That's actually the last one I graphed just a moment ago, was the flip and the stretch there on number 10. I want you to graph at your seats number 16. Go and graph number 16. I think you can use the same graph grid you used a moment ago. So you only have one parabola on there so far. Switch to a different color or a different writing utensil of some kind. And let's do number 16 there on your paper. Do you feel blessed?
I do.
All right, how many have that? You went down 2 and you flipped it. All right, do number 18. Number 18. Might be able to use the same graph grid.
keep going down?
Good question. Shift down. It's not flipped. Thank you. I was seeing if you were paying attention. Good job, Michael.
Thank you.
Okay, I was like, I said it too. You just couldn't hear me.
Doesn't count.
Whatever.
It doesn't count.
Let's try that. Do we like that one better? All right, that doesn't fall on top of the other one either, which is kind of nice. All right, let's see. Maybe set up a new graph grid, and let's do number 20. I'm going to do a few more, so a new graph grid would be an appropriate time at this point, because I think most of you have 3 on one grid already. So set up a new grid for the last few. Again, dealing with the fractions, always fun counting it out, making sure we get everything just right. And here I did go ahead and go all the way to the 7/8, where 7 halves, or 3 1/2. So counting carefully. Again, we're going to start down 3, over 1 up just half a unit, then up 3 halves, or 1 1/2 units, then up 2 1/2, then up 3 1/2, 7 halves. So half, 1 1/2, 2 1/2, 3 1/2. Put me right there at the 5 on the y-axis. How many had that for this one here? All right. I'm going to have to set up a new graph grid, but at your seats you can do 24. Number 24. Three changes. go on 24? All right, if so, go on to 26. We'll do this as our last one for today. Any questions on 24? Any questions on 24? And there we see number 26, 4 changes. Back 2, up 9, flip it, and stretch it 2. It's about as complicated as we can make it. And if there's only 4 things we can change, we done changed all 4 right there. Questions? For homework, you're going to try 5 of these. So maybe the first 3 on one graph grid, the next 2 on another. You're also looking at a quiz tomorrow over parabolas. So this homework is going to give you a good review for that. Page 209, do numbers 15, 17, 19, 23, and 25. 15, 17, 19, 23, and 25 as we wrap up parabolas. All right, have a wonderful rest of your day, and you are dismissed.